Hello. I welcome you all to this another interesting screencast. The problem reads: It is observed that the skier leaves the ramp A at an angle theta A equal to 25 degrees with the horizontal. If he strikes the ground at B, determine his initial speed VA and the time of flight TAB. In the second case, it is observed that the skier leaves the ramp A at an angle theta A equal to 25 degrees with the horizontal. If he strikes the ground at B, determine his initial speed VA and the speed at which he strikes the ground. Both these problems are coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. A quick reminder of the basics. Where can I write? So we have velocity, which is the time derivative of position. We do have acceleration, which is the time derivative of velocity. From the two equations, we do have the derived equation A ds B dv. From the three basic kinematic equations, we are able to derive quite a couple of equations depending on the boundary conditions. But of course, we do have the common one. When acceleration is constant at t equal to 0, we have S naught and V naught. Using these boundary conditions, we are able to derive the basic three equations that we usually use when acceleration is constant. We have S equal to S naught plus V naught t plus half ACT squared. Then we do have another one, V is equal to V naught plus ACT, and finally V squared is equal to V naught squared plus 2 ACS minus S naught. Okay, so let's begin working on this particular problem. Before we do so, let's add some details. We are going to have a vertical component there like so, and a horizontal component which is always constant, right? Here we are going to have the final velocity, which will have also its components. It will have a horizontal component like so, and vertical component like so. So let's label them. So let's say this is our VB, and then maybe we say this is our theta B. Okay, and then we say this is VBX, which is equal to VAX. This one is VBY. Okay. Alright, of course, this is theta A here. This is theta A, which is 25 degrees. And therefore, this is our VAY, which is equal to VA sine 25. And this is our VAX, which is equal to this one is equal to VA cos 25. And then additional more information that we need, this part here, this part we are going to use this part as well, so we need to try and add some more information to this, right? These dimensions, we need them, as well as this. Okay, let's clean it up a little bit. So there we go, something like so, something like so, great. And also this, something like so. I think this is good enough. So we are saying this one here, it is 100. 100 by 4 divided by 5. And this one is 100 by 3 divided by 5. Right? Great. So what do we do now? Well, we are going to, I think, apply this equation. What are we looking for? Vm as well as the time of flight. I think this one for me is okay. And then later on, they're asking us for the speed. All right. For the speed, this one will come in handy also. So I'll check this one later on. Let's start with the first case. So let's say case 12-96. All right. So let's work out what we are looking for in this particular case. Of course, we'll start with the horizontal motion. We'll start with the horizontal motion. Let me write it there. Horizontal motion. And then under this, we are using the equation S is equal to S naught plus V naught T plus half AC T squared. Our S is equal to horizontal, that's 100 by 4 divided by 5, which is just equal to 5 into that is 20 by 4, that is 80, right? Of course, this is 80, and then we have S naught is equal to 0. Mind you, this one will be my reference. Okay, that's my reference. And then we have AC equal to 0, okay, in the horizontal. And then V naught is equal to VAX, which is equal to VA cos 25. Therefore, we are going to have an equation AT is equal to VA cos 25 times T. Okay, I'll make VA subject to the formula. This just becomes equal to AT divided by T cos 25. Right, so let's go to the vertical motion. So we have vertical motion like so. And like we said, we are using the same equation, S equal to S naught plus V naught T half ACT squared. Our S in our case here, that's vertical motion, is 100 3/5 plus 4, and this is equal to 64, right? Then we have S naught, sorry, this is S naught. S naught is equal to 100 3/5 plus 4 equal to 64, right? That's S naught. And then we have S, which is just equal to 0. Then we have V naught, which is equal to VAY, which is equal to VA sine 25. And then finally AC is equal to minus 9.81. Therefore, we'll have a 0 equal to 64 plus VA sine 25, right, by T minus half 9.81 t squared. So let's fit this value. Okay, let me maybe use this root. I use this root like so. We feed it there. Right. Once we do so, let me just create a boundary so that I shift my working space. Right, there we go. Okay, so writing this, we can have a 4.905 t squared equal to a 64 plus 80 divided by t cos 25, and then we have sine 25t, right? Then the t and the t cancels, and therefore we have t equal to plus or minus, but we are not interested in the minus, we're only interested in the positive. So we have 64 plus 80 tan 25. Then divided by 4.905, and square root of that, we have a 4.54 seconds. Okay, therefore our time of flight, okay, for TAB is equal to 4.54 seconds. All right. So let's use this equation now to find our VA, this one. Okay. So finding our VA, we are going to use this equation. We said VA is equal to 80 divided by t cos 25. And our t is equal to 4.54. And therefore, our VA is just going to be equal to 4.54 cos 25, 80 divided by, answer we have a 19.44 meters per second. A 19.44 meters per second. So 80 divided by 4.54 cos 25, 19.44. So let's go to case 2, which is 12-97. Alright. So in this particular case, we have been asked to find the speed at which it strikes the ground. Here we'll only be interested to find VBY, because VBX is equal to VAX. So we are going to use this equation. So we'll say using V equal to V naught plus ACT to find VBY. Mind you, we are dealing with vertical motion. We'll say VBY is equal to our V naught is equal to 19.44 sine 25 minus 9.81 times the time, 4.54. Therefore, VBY is just going to be equal to 19.44 sine 25 minus 9.81 by 4.54. This gives us a minus 36.32, okay, meters per second. So 19.44 sine 25 minus 9.81 times 4.54, 36.32. Then our VBX is equal to VAX, which is equal to 19.44 cos 25. Okay, let me just move this. I just moved them a little bit, maybe this side like so. Alright, so with this information we can therefore find VB, which is just equal to the square root of the 2 VBX squared plus VBY squared. Therefore, our VB is just going to be equal to 19.44 cos 25 squared plus 36.32 squared, square root of that, we have a 40.37 meters per second. So a 19.44 cos 25 squared plus 36.32 squared, square root of that, we have a 40.37. I guess we are done. Let's outline the solutions. We have the time of flight from A to B of the skier, and we have the skier's initial velocity VA and final velocity VB. Right. I think this is about it, and I hope this video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.